This is earlier one. Okay. So, yesterday in the last class, what we discussed, we just starting from Maxwell's equation, we have derived the wave equation for free space and homogeneous medium. Okay, and then ultimately we found that the equations, so-called wave equation or Helmholtz wave equation, so I just concentrate only on electric field, and obviously we just consider that electric field x, y, z, t, that can be just simply written as space dependent part and only single frequency j omega t. So if it is so, then directly using your curl equation you can just arrive to this equation, and where we simplified that your ES, that means the electric field, instead of three-dimensional dependency x, y, z, let us consider that it is only varying along z direction in a spatial way. Okay. Similarly, if you just think of magnetic field, also associated magnetic field, that you can also say that it is varying only along z. Okay, and their vectors, that means their direction need not be same, they can be different. Okay, and assuming this one again further, we just consider as only having x component. So only having x component, and it can vary along z direction. Okay, so from the Maxwell's equation, curl equation, it can be shown that this one can be represented as only y component, and z dependencies will be there. So x direction and y direction we can say. So if you just think of this one, that means this electric field does not depend on y, does not depend on x, but it is oscillating, only x component is there, vector is there. So that means if I just start from here, that if I just try to do this one, del square, which is actually equal to del x square plus del y square plus this one, right? So knowing the information that electric field only z dependent, so this can be reduced to simple differential equation, xs z d2 dz2, right? And then omega angular frequency, omega c square, and ex s z equal to 0. Okay, I have not used now the vector sign, that means direction of the electric field, because it's the same direction, so I just removed. It is, if it is just one of the coordinate, main coordinate, principal coordinate x, y, z, so then we can use it as a scalar equation. So So this can be considered as a scalar. No more vector you need to consider. But the information is that you know that electric field is oscillating along x direction. In fact, that is a vector, but I have created some situation or assumption such that we can solve the equation similar to like a scalar wave equation. Okay, and this one we can actually write down something like this. Xs, I should write x component as. So you should not be confused that if it is x component is there, that does not mean that it has to be x dependent. It is x direction, x component. It is a field. Force is there along x direction, but need not be x dependent. Sorry. Oh, sorry. What is this? So this thing should be there. Okay. So this one, and you know, we normally write omega by c is equal to, you know, omega equal to your, we know that omega equal to 2 pi c by lambda in free space, right? 2 pi by lambda, 2 pi by c by lambda means it is f. That is actually 2 pi by f or nu, optical frequency 2 pi by nu, right? And omega by c equal to 2 pi over lambda, and that we know that is actually inverse of lambda times 2 pi, that we are considering as a phase constant or propagation constant. Phase constant means, you know, lambda. So you know, if any wave traveling in a certain direction, if it travels lambda distance, then it acquires 2 pi phase shift. So that means 2 pi by lambda means per unit distance of traveling, how much phase actually it acquires. That's why it is called phase constant. So per unit length, this amount of phase will be acquired by the electromagnetic wave when it is propagating in free space. Obviously, if it is a medium, then you know this lambda inside the medium, lambda will be changed. Okay, lambda will be changed. It will be scaled with a refractive index, lambda over n. That will be refractive index. So in that case, it will be omega by c will be 2 pi by lambda. You can write, but this k can be written as additional term. We write, maybe we can consider like beta. This is if this is called considered as a free space, but if it is material medium, we can write refractive index times k, nk. So something like that we can write. Refractive index has to be multiplied, where k equal to consider your propagation constant in free space. Sometimes also, if we just consider k in the material medium, then we can consider k naught is equivalent to k naught equal to 2 pi by lambda is equivalent to your free space, and k means 2 pi by lambda times refractive index. Okay, so that thing, if it is free space or material medium, whatever, we can write k, that is k square E xs z equal to 0. So this equation, if you see, it's very simple. You can easily solve. What would be the solution of this? Can anyone guess?
It's depend on value of k. If it's 0, then it should be linear. If
No,
it's
k must not be 0, right?
no, it must be positive. So it's sine cosine, a linear combination of sine cosine.
Linear combination of sine cosine type things, you will be getting a solution. So we can assume easily that this EXS, that is space dependent part, obviously it will be z, and second order derivative is there. We can easily write this one as 0 x, something like that we are writing here. It's plus minus j k z. You see, so k can be plus minus, right? Solutions, both solution valid. So if you are just inserting this one in that equation, it will satisfy, where E0x is the constant, some constant. You can consider it as a amplitude, right? So in that case, you know that our originally we consider that electric field also it varies as time dependent e to the power j omega t. So that means my total electric field I can write by this assumption that it has only X component, only Z dependent variations are there. Z dependent variation, again you see it is coming like a sinusoidal, e to the power plus minus jkz, sine, cosine, or whatever consider, it is in the complex form we are writing. So in that case, E can be written as Z dependent and time dependent, right? That should be something like that. X direction, unit vector, amplitude, X component, and e to the power j omega t plus minus kz. Okay, I know all of you know, you are aware about this type of equation. Now this type of equation is something we can use as a plane wave equation for electromagnetic wave, and similarly in the same fashion you can solve the magnetic field. That also will be Z and time dependent, and we know that from Maxwell's Carl equation you can show that that will be actually y direction, it will be oscillating along y direction, and it will have y component, and similarly this factor will be same because equations are similar. Okay, so this is for electric field and this is for magnetic field solution. For this special assumption, this type of situation you can create your surroundings, you can create that electromagnetic field will have electric field like this and magnetic field will be like this. So what is their similarity? If you see, one thing is that they can be in different direction, mostly it is orthogonal direction it will appear, and this phase part is similar. Okay, this e to the power j omega t plus minus kz, that they are similar. So that means if it is particularly if it is k simply 2 pi by lambda, that means just a constant, that means you can closing your eye you can say that okay, this electric field and magnetic field, they both are in phase. Okay, but in case of something you say that this obviously they are in phase whenever you are assuming this part E0x, this amplitude part, A0y part, you are considering real. But there are situations where you will find that this amplitude, they can be also expressed in a complex form that will have a real part and that will have an imaginary part also. So that also will show that from the Maxwell's equation it also satisfies. So in that case I can say that this electric field and magnetic field can be out of phase also. K, whatever it is value, 2 pi by lambda n, if it is material medium n, or it is some kind of refractive index which is actually which will have some kind of real part and also some part of say kappa, something like this, kappa, not k, kappa. So that means if it is a complex refractive index, then you can see this one and this one, in spite of that complexity, because it is in the phasor form, both electric field, magnetic field, that part is actually identical, so they are in phase. Only thing is that if their amplitudes are complex, and of course their real part, imaginary part, if it is different, they can go out of phase. Okay, but can anyone tell that if suppose your refractive index appears to be complex like this, right, then what you conclude of this electromagnetic wave?
It's an exponentially decreasing, like
It
the
will be
amplitude will decrease exponentially.
because n, if you are just multiplying here and then plus minus form is there and we multiply, then it will be something like that, minus kappa or plus kappa will be there, right? 2 pi by lambda kappa or minus 2 pi by kappa lambda. That means if your refractive index, if you are expressing in case of complex something like that complex, then either it will be the electric field As it travels, it will be exponentially decaying, or exponentially it will be gaining, amplifying. So that means we can easily say that if a material medium is having some kind of lossy term is there, loss is there, scattering loss or absorption loss or whatever, that means that is due to the complex refractive index. Even if it is gain is there, that also gain medium also you can just represent by assuming refractive index as a complex. Okay, so the absorption or gain, that depends on whether you are using plus or minus sign. So that plus and minus sign, it will come depending on the property of the material medium, what it offers to electromagnetic wave, whether it is offering some loss, absorption, or it is offering some gain. So depending on that, you can actually modify that thing. And obviously their amplitude can be different, that we'll see from Maxwell's equation. They can go out of phase also. Okay, that is the thing. Now next question, suppose you are considering omega t plus minus kz, omega t plus minus kz. So if you consider plus, what you will interpret with that, and minus, what is the difference between plus and minus? Is there any difference, or their meaning same?
Yes, sir. Backward wave and forward wave.
Which one is backward? Which one backward? Which one forward?
Minus is the forward and plus is backward.
How you conclude that? Anyone?
In the definition of the wave equation, like f of x comma t, we take a minus z minus x to be that like t minus x by v to be positive x wave.
No, that is actually because it is so. That's why we consider it is so. It is actually practically that is the case. When minus you assume, then it is actually meaning for positive, traveling in the positive direction. And if you consider plus, it means traveling in the negative direction. That is because of the actual physical meaning, physically that happens. But mathematically, I'm asking how you conclude that.
I have to take omega t plus minus kz equal to some constant c. Now I am in origin, put x equal to 0 and t equal to 0. Then c is
right.
0.
I think Rishabh, you are right. I think you have to consider that at certain instant of time and certain position you can consider t1 and z1. Now another instant of time, if you see t1 and z2. Now if this two instant of time, if you are considering that phase is identical, right? For example, omega t1 minus k1 z1 equal to omega t2 minus k z2. These are the phase, right? So at t1 you have position z1, at t2 position z2. You are just considering two instant of time and corresponding to two positions where you see phase are identical, right? That means I am just looking identical phase where it is occurring, where and when it is occurring, right? So that means this will occur because of the traveling nature of the wave, phase will be identical. So you try to find out that z2 minus z1 by t2 minus t1. That means traveling distance divided by time. That means identical phase, traveling distance, you have to identify, and then you can get what is the, whether it is coming positive or negative. If you find that that is coming positive, that means that it is traveling in the positive direction. If it is negative, somehow negative, it is coming z1 less than z2, then it will be negative. So that is a qualitatively, I'm just in a hand waving way, I am just expressing, because I don't want to go that details. At least you can, all of you can find out why that is actually meaningful. These are very important. I know that a lot of you, many of you, you can easily say this is the thing, but ultimately when we ask, can you interpret why? Normally you struggle that time. So you just think about that and try to confirm that it is indeed meaning for the traveling in the positive direction, negative direction. In the same way, if I say consider, you know, whenever I am considering this e to the power j omega t, I can consider e to the power j omega t or e to the power minus j omega t. They are same. Real parts are same, right? E to the power j omega t or e to the power minus j omega t. So suppose it's a mathematically how you are dealing electromagnetic wave, right? So if it is minus, so in that case, plus minus here also plus minus kz will be completely opposite. If you are using minus j omega t, that means when you are considering plus kz, that will be traveling in the positive direction, and minus kz, that will be in the negative direction. So depending on what sign you are using into e to the power j omega t, that actually gives your consequence whether plus kz is traveling in the positive direction or negative direction. Okay, so this thing should be clear about that. Okay, right. So we understand that from this simple example, we could explain that the electromagnetic wave, how mathematically we can represent traveling in the positive direction, traveling in the negative direction, and the gain medium, lossy medium, all those type of you have considered here. So in case of material medium, instead of k, we can consider beta, or this n can be considered square root of epsilon r or so on. If it is real, then fine. Otherwise, it will be considered like this, right? So far so good. So now we'll be just thinking little bit differently. Okay, little bit. I will go in general type of solution. Suppose whatever I have considered here one dimensional, and electric field is in the positive x direction. It's oscillating along x direction. But suppose your system, your device, your material, whatever you are using for handling electromagnetic wave, that is in the lab, right? So you have x direction, y direction, z direction. You can define based on your whatever material medium you are using. So in that case, you are dealing some electromagnetic wave. That electromagnetic wave will have electric field in an arbitrary direction, or polarization in an arbitrary direction, and it can it not like along x direction, y direction, or z direction. You cannot define. It can have x component as well as y component, and it can have x component, y component, z component of your electric field. Suppose you are considering your electric field in this direction, x direction, this is y direction, this is z direction. So, and you are dealing electromagnetic field where electric field will have all the three components or two components. Not necessarily it will have to be only along x direction or only along y direction or z direction. And also your wave need not be traveling here. Wave is traveling along z direction, right? Only z dependent variation you are showing. So wave need not be traveling along z direction. So that means wave can have can propagate in different direction. That means this k actually I have to represent as vector, right? So in that case we can write that ax kx plus ay ky plus az kz, right? So that means I have, if with my reference system, laboratory system, material medium, it has a fixed x-axis, y-axis, z-axis. With respect to that, if I want to see my wave is propagating along k direction, some arbitrary direction where I have kx component is there also, ky component is there also, kz component is also there. So at the same time, I will have ex component, ey component. You can have ez component, you can have hx component, you can have hy component, you can have hz component, and all of them can be x, y, z dependent. All the components, every component, ex can be also space dependent, ui also can be xyz dependent, ez can be also xyz dependent, hx also same, hy also same, hz also all space dependent things. But another thing also you should keep in mind that all of them space dependent, and if they are originating from single frequency, you can assume also that each of them oscillating with same time constant, same time function. That means harmonic function omega t. Omega is the frequency. So that means this idea you have to keep in mind, that I have to handle 6 different components. Ex, Ey, Ez, Hx, Hy, Hz. Similarly, I have to handle three different components of the wave vector kx, ky, kz, right? So in that case, position, if I am just considering three-dimensional case, any position if I want to define in the space, that can have also x component, y component, z component. That means I can define my any position I want to find, for example, at R, what is the electric field in some Cartesian. It is not Cartesian. R is actually what spherical coordinate system or whatever coordinate system you are just trying to find, but you can decompose them into say ax x plus ay y plus az z. X y z coordinate you can represent with a r position vector, okay, in a vector form, because I have to deal with all the vector components, so I can write like that. So if this is the case, now how we will define our solution for a wave equation I have represented earlier, that is actually like this: omega square c square, and if you have dielectric constant epsilon r is there, so you can write like this, right? No, this is not square, right? Okay, del square omega square by c square e square epsilon, this one equal to 0, right? And we have identical equation you can write for magnetic field, right? So in that case, whatever the solution I write, I have to write same thing, na? Es x y z, that is the space dependent part, and this Es will have Ex component, Exs, Eys, S for space, standing for space, okay, Eys, Ezs, and then we can write this is oscillating with j omega t, right? Like this we can write. So now this solution, it is a traveling wave solution we supposed to get, right? So that means the wave is traveling in a certain direction. Okay, now I want to represent a wave in xyz in terms of k. Again, this one I can write always, this together I can write always equal to k square, omega square by c square. I can write omega square by c square epsilon r as a k square. Okay, that is k square means k square. That means I can write k dot k, right? Or beta, if it is a wave vector, I can write like that. Epsilon r can be 1 also in free space. Okay, so this is the case. So if I try to solve this one, and in terms of k vector I want to incorporate in our plane wave solutions, what would be the modified equation? Anyone? E can be written as, okay,
E power j omega t plus k bar dot r bar.
yes. So it will have some kind of E0s vector sign. It can be x, y, z dependent, and e to the power j omega t instead of kz, I can write plus minus k dot r. So kz, because both are vector, position z is not like just along that axis, and k is not just along also kx, kz. So it depends on which direction. You have to take basically dot product of k vector as well as r product. That will account for your phase at that particular point. And I think most of the time we won't deal with always the plus minus. We can consider electromagnetic wave only propagating in the positive direction. Okay, I can write like that. And if it is you are writing minus j omega t, then you have to write plus k dot r. Okay, so this is your electric field representation in just general form in any arbitrary direction if it is propagating. Good. So similarly, magnetic field also you can express like that. Now, so once we know this, that okay, electric field is this one. Can we just go back Maxwell's equation? Because normally in this part, if you are seeing here, okay, it is actually just space dependent solutions you are getting. Sometimes in this type of situation, when E equal to this one, and then you can also write H equal to magnetic field equal to say something H S X Y Z e to the power j omega t minus k dot r. So this way you are representing. So suppose I want to know what is the relationship, because this is, I have now three vectors, E vector, H vector and K vector. Of course, along with that you have a position vector at particular position what you are getting. Now if I just go back to your Carl equation, for example, Maxwell's Carl equation, first equation, you can just write simply like this, right? And keeping in mind the fact that it is only one frequency is involved. So this one can be written as minus j omega mu, it should be mu naught if it is free space, and homogeneous medium it is mu hs. So this is actually we call this one instead of minus del d del t, because del t instead of del t I can write j omega. That operator is j omega, because once you do time dependent derivative, that means j omega will come. Minus sign always is there. So this type of equation also, sometimes some books you will see that Maxwell's equation they are written like this form, and it is called actually frequency domain Maxwell's equation, just because only one frequency you are getting. If you change frequency, then accordingly everything will be changed. Frequency is considered as a constant here, right? So now my question is, if you somehow this is the instead of ES you can write, because e to the power j omega t already you have factor from both sides e to the power j omega t. Now without considering e to the power j omega t, without considering e to the power j omega t, because that can be factored time dependent part already, instead of del t I have just written minus j omega. And if I just substitute this one here, okay, so if you just substitute and try to evaluate the del operator, what you will get? You will get del ES is given here, and you can consider ES is having your X component, Y component, Z component. K you consider KXX. So this one means you can write K times X plus KY Y plus KZ Z. So this K dot R can be written like this, right? So if you just use this one and you assume that there are three components, all you substitute here, and after substituting you will get something again simplified form like minus j k, right? Minus j k cross ES equals to minus j omega mu hs. So this is the simple form you will be getting. That means this del is actually equivalent to, you are getting like minus jk. Del operator, if you are considering this equation, this del operator in vector form, it will be minus jk, right? Any question till now? So if you solve a little bit, that you just substitute k value here. Let us consider this one. You can write like this, minus j cancel, right? So k equal to, I can write omega over c and then certain unit vector along k direction. We write ak, right? And you can say that omega by c ak, and of course you can write down the, if material medium, square root of epsilon r will be there. That is the refractive index. Okay, left hand side I can write like this. First term. and then we can write cross ES. Okay, cross ES equal to, you can write omega mu HS. Omega cancel, right? And this one ES, you can write again something like that. ES, you can write something that ES mode of, and then electric field direction, some arbitrary direction it will be there, and that direction unit vector I write like this. Then what we can write? We can write AK AE, right, times ES by HS, right? HS I am taking this side, and then right hand side what I will be writing? I will be writing mu C, C times mu divided by epsilon r, C times mu divided by epsilon r. That will be written as mu by it will be mu by epsilon. What you will be writing? Mu, sorry, I can just simply put down there whatever the value. So I can write here mu times C divided by square root of epsilon r. Mu times C, C again you know, C equal to mu, and C means square root of mu 0 epsilon 0, right, and epsilon r, and here mu 0 mu r, for example mu r equal to 1 you can consider. So that means square root of mu 0 by epsilon 0, that means I can get eta 0 by square root of epsilon r. Eta means what? So eta not equal to square root of mu 0 epsilon 0. That is actually called intrinsic impedance for the free space, we know that. So we are simultaneously getting, and one more thing will be there, I missed that one. What I missed, you know? Anyone can point out? Right hand side, what I missed? No one? Jaswant? Jaswant, are you there?
Yes, sir.
Tell. I'm asking you a question, you know or not? Right hand side, what is wrong? Something I did mistake in the right hand side.
So left hand side equation is a vector, while right hand side we are taking
Yes.
as a scalar.
Right, exactly. So you have to write that magnetic field that will have certain direction, right? So what I get here, AKAE and equal to AH. That means electric field must be perpendicular to the plane where AK and AE, propagation direction and electric field direction. And another way you can say that they are, if it is a free space, they are all mutually perpendicular to each other. Electric field, propagation constant, and propagation vector or wave vector, we sometimes call it wave vector, unit vector, and they are perpendicular. And you see, if they are unit vector, this one is the unit vector cross product, and this is unit vector. And then ES by HS we get, you know, that is we normally know that ES by HS. So that is actually your eta 0 by epsilon r. Normally, you know, that is actually we call it, this is eta. It is normally, if it is any medium, it is actually eta. Eta is nothing but square root of mu by epsilon. Okay. That is actually impedance, characteristics impedance, so-called characteristics impedance. And similarly, from the divergence equation, you know divergence of in homogeneous medium, divergence of E equal to 0 and divergence of H equal to 0. So in that case, we can also show that K and E, that is actually equal to 0 and K dot H equal to 0. So that means your K vector and K vector simultaneously perpendicular to the both electric field and magnetic field. All right. So this is one thing, and the next thing is, so far we have considered that material medium is homogeneous and or free space. Then continuous homogeneous, no boundary, nothing we have considered. But whenever you are talking about your integrated optics or waveguide, you need some kind of, we have shown that you need a core. In homogeneous medium, you have a cladding. That means you have to have some kind of material property change is required to tame, to control electromagnetic wave, to design waveguide. All those type of things is required. So we cannot really deal with all this very simplified form, but this all gives us a very good understanding how what electromagnetic wave means and how electric field, magnetic field, their behavior, their relationship, everything we understand. But normally any material medium, you know, whenever we talk about integrated photonics, photonic integrated circuit or waveguide or whatever, and electromagnetic wave, you have to deal with it. So when electromagnetic is talking to material medium, it talks through three important parameter. We are showing mu, epsilon, and the third one is sigma, that you know. And so far we consider this sigma equal to 0. Dielectric medium we consider. But you will not get any material where sigma equal to 0. For example, if you are using a silicon waveguide, sigma cannot be completely equal to 0, though we can consider it is transparent, something like that, but there will be some kind of free carriers will be there, and that will contribute to loss, etc. So sigma conductivity will be there, right? So in that case, normally we know that when sigma is there, that medium is called lossy medium. Some loss will be there, attenuation factor will be there, and if you are not considering sigma, epsilon, mu is there, all are there, and still it is kind of homogeneous medium you are considering, then your wave equation will not be that simple. You have to consider something like this. I think directly from the Maxwell's equation you will get. I am just not starting from beginning. I am just writing the result. J omega mu sigma J omega epsilon. Sigma is coming now, equal to plus E equal to 0. Sorry, multiplied by G. You just remember, if you are just putting sigma equal to 0, you are getting your original equation. Omega square mu epsilon. Mu epsilon means 1 by c square. So omega square by c square if sigma equal to 0. If sigma is there, so you have to consider this term. Similarly, we consider sorry, J epsilon H. So you have to solve this equation. If sigma is not there, then sigma is non-zero, then you have to solve, including sigma. That's a little bit complicated, right? You have some kind of complex form is coming, right? J is there, J is there. So it's a bit of difficulty is there. But what we do, we consider this one, simplify it, we represent it as a complex term called gamma. So this actually, if we are writing gamma square, then it is a simple equation, right? We can write something like that. Sorry. We can write this one equal to gamma square E, that is actually equal to, that is again, if I just consider gamma, but we are considering this gamma is now, gamma square is now a complex value. Okay. So that complex value I can solve separately once I get a solution, and then ultimately we can see how electromagnetic wave depends on gamma, and then gamma, all this parameter we insert back and we can see the property. And if you just look a little bit carefully, this gamma equal to square root of j omega mu sigma j omega epsilon, right? So this is again, if you just get square root, that will be actually, again, it will be complex. We call that one is alpha plus j beta type expression we can write down. Okay. So if gamma equal to this one, and this one you can solve a little bit, simplify a bit, then you can actually both side, you can find real part and real part. It will have real part, it will have imaginary part. Real part you equate to alpha, and imaginary part you can equate to beta. Okay. So if you do that, that alpha value will be, and just directly writing, you will get all these in your electromagnetic, any book you can find out. So omega times mu epsilon by 2, yes, and then 1 plus sigma by omega epsilon square. Let me clarify this thing. So 1 plus sigma over omega epsilon square, right? And then square root. The square root minus 1. That is your alpha value. If you solve, you can, I think all of you can try also as a home task. Beta will be equal to 1 over sigma by omega epsilon square plus 1. Okay. So this is your alpha and beta. If you just simply put sigma equal to 0, then all the earlier treatment you got, exactly will be getting that alpha, and beta will be, if sigma equal to 0, alpha will be equal to 0. Right? This will be 1, sigma equal to 0 means this is 1, 1 minus 1 equal to 0, 0 times this one, 0. Alpha will be 0. And beta will be sigma, if you just get 0, that means it is becoming as a 1, plus 1 is there. So that means mu epsilon by 2 and omega is there. So only beta expression you will be getting. Okay. That means whenever you are getting gamma and when sigma equal to 0, then only you will be getting j beta, which is j beta is nothing but earlier solution. Here we have used plus k square value, right? So if you just insert, you can get some kind of complex solution if alpha and beta both are non-zero, if you are getting. Okay. So in this case, the solutions you can just simply written as, write as ES will be equal to some 0s, it can be x, y, z dependent. Okay. And e to the power you can write, say plus minus gamma, the solution of this one, plus minus gamma, plus minus gamma. If it is propagating along z direction, you can write only z. Otherwise, you have to write something gamma as a vector, together vector and dot r. That way we can write here. Okay. So I stop here today. I'll continue maybe from tomorrow. I will just discuss maybe, I think you know total internal reflection. If I ask all of you, what is total internal reflection, you all know, you will be able to explain. But I will start with a very interesting question where you will not be able to answer, I'm sure. Most of you, I guess. So that I will be starting in the next class. Okay. Any question?